I am here to talk about building trust using mTLS for secure baby monitor connections. Before I start, I just want to quickly talk about myself. So, who am I? I've been an iOS engineer since 2015, so seen quite some things, big companies, startups, lots of stuff. Sometimes I deviate from iOS and do other things as well. I've been very much into 3D printing recently. Because I wanted to create my own stuff for 3D printing, I am a developer. I did not want to use a mouse and a CAD, so I decided to just write code that I can print on my 3D printer. Very niche. Who does that? Who does write code for 3D printing? I started sharing that online on Instagram like 3 months ago. It seems like people will actually like it. I got a lot of followers, so if you want to follow me there. I got some viral videos going on. I got one that I posted like 2 days ago, and it hit like 14 million views, which is a lot. I am starting to share content in English as well. My main account is in Portuguese, but maybe I'll put some English subtitles eventually. So, I did bring some very nice keychains, like Swift and Xcode keychains that I made myself on my printer. Just follow me and find me in the rest of the conference, ask for one. I brought many, not for everybody, but a lot. So, I say this to tell you that I am not a security person. I am not an expert in this. I don't usually focus on security at all. But I do have a good reason to care about this, which is the little tiny hacker that lives in my house and eats my food. She had only 2.5 years of experience when I took this video. And yes, a little bit of a vibe coder. She vibe codes everything, but very, very successful. Every time she touches my code, she breaks it. It is every time. I think until she learns git commit and git push, I'm safe. But until then, well, she's gonna have 18 years of experience when she graduates high school. So just be aware. But to protect those little tiny hackers from the big bad hackers, IoT cameras are known for being vulnerable. A lot of cameras are not secure. They have a very bad reputation. They could be hackable. There's a lot of news around. And if you ask a parent with a baby that you want to put a camera in a room pointing to a baby, ask them like if they want their banking app hacked or the baby monitor camera hacked. They will tell you, take my money, but don't take the camera. So we do not need to be very careful with security when we're talking about baby cameras. So in this presentation, I'm going to cover a couple things about security. Going to explain a bit about certificate pinning. Going to explain what is mTLS that many of you might never heard of. How to implement this in Swift. And some of the challenges that I had to go through to get this to work all the way. And before I even start, I just want to set everybody here on a level of what is a private key and public key at a very high level. I'm going to talk about private and public key a lot in this presentation. So, public key basically encrypts things. You use a public key to encrypt something, a message, and only the owner of the private key can decrypt and actually read whatever was in there. But there's also like a second use to this that could be very useful. A private key can be used to sign something. So I want for this server to prove they own the private key, but how are we going to prove they own the private key? They cannot just send the private key to prove they have it. So they sign something, and I can verify that was signed by the private key, and I know that server actually has the private key without telling me what the private key is. All right, so some topics about network security. And by network security here, I'm focusing on trying to steal information over the network. So a lot of those hacking news that you saw, the problem is accessing the camera or stealing information from your app without having access to the device itself. So the device is fine, but you're connected to a hotel Wi-Fi or a conference Wi-Fi, and they can steal information, which is not good. So we want to protect all the way on the network, even without having access to a compromised device. So very, very simple, an HTTP request. Talking about mobile, you open a connection to the server, request something, it gives you back. Everything is plain text. Even like your cell phone company can read what's in that request. Everybody can read it very easily. We don't use that anymore. That's how HTTPS comes for. HTTPS is secure. How secure? So when we create a connection to the server is going to send back a certificate proving that they are who they say they are. That certificate also contains the public key. So the app, under the hood, the OS level, is extracting that public key, encrypting everything. So now all the information is encrypted, and only the server can decrypt because the server has the private key. But there's a problem here, which is the man-in-the-middle attack, which I am going to rephrase to person-in-the-middle attack, because women can also be bad people as well, like be inclusive. So what is this attack? Someone pretends to be your server, actively pretending to be your server, and they pass in a different valid certificate that your app might or might not accept. And if they do it, the things just the right way, they can trick the system into accepting that certificate. And now, instead of encrypting to your server, you're encrypting to the hacker, and the hacker is reading everything that's going through. So that's not good. We don't want anyone to be able to read it. It is not easy to perform this person-in-the-middle attack. So there's something called certificate transparency, which is basically when your server, it's a public API that anybody could call. Of course, nobody would enter, but anybody can call. And it has a certificate that was issued by a certificate authority. And just in summarizing, they will make sure that those certificates are valid, and they have like a public log that the certificate is good. Apple is going to verify that, and so it's going to be verified. And if someone issues a certificate for your server, you're going to get a notification. But still, for most apps, this is enough. This is just good enough for security. But for some applications that you want to step up on the security, for banking applications or for something that's very sensitive, do recommend certificate pinning, which is the next step. Certificate pinning is simple. If I know what my server looks like, I will get the certificate from the server, put it inside the app, do a match. If they match, I'm talking to the right server. If they don't match, I will kill the connection and just not answer anything. But now we're talking about an IoT camera. That's what I'm talking here. The camera is acting like a server. I make connections to it with like GET requests, I open WebSockets, all of that. But it is bad if someone pretends to be a camera and steals information from the app. But it is bad. Probably worse if someone pretends to be an app and steal information from the camera. So they could access the video, images, whatever is inside the camera. So you see that they're both in the same level, and they both need to verify each other. And that's what mTLS basically is. When we establish a connection, the camera sends me their certificates. I validate them with certificate pinning. Then I pass in my certificates to the camera. The camera is going to validate on their side. And if everything goes correctly, only then the connection is established, and then we can talk to each other. So this is what mTLS is. So just to recap a little bit, certificate pinning is making sure it's a valid certificate, but also if it matches exactly a trusted server that you know, it's your backend and it's this specific backend. And it's quite easy to implement. You do have to take some things in consideration, but it's not too hard. mTLS, on the other hand, both sides are validating each other using certificates. It does include a signature validation that proves you own the private key. I will come back to it later, but this is one of the interesting stuff that happens. All right, so let's talk about some code. I did explain this to my baby, and she understood every single line, so I think you're going to be able to follow what I do here. I'm not going to go too deep. All right, so basic things. You do a URL session delegate when you call, and then you get that function. So URL session, and you get this function to receive a challenge, an async function. When you get there, you're going to perform your own validation for it. And if the validation fails, something went wrong, you cancel the challenge. Just to be safe, you're going to cancel the connection and not continue. It doesn't matter why it failed. It could be many reasons, but to be safe, we can cancel it. All right, so if we're talking SSL pinning, which is what most apps would go to, you implement that function, check if it's a authentication method, server trust, do your thing, and return that function. And if you're doing mTLS, which is the next step that most apps are never going to do, but still, you're going to check for a client certificate, and then you're going to return with your client certificate. Sounds very simple. Just wait a little bit. So SSL pinning is not that hard. There's two main ways of doing it. The first one, get your entire certificate, put it in the bundle, do a match with the server, and move on with your life. That's very easy to implement, but certificates do expire every year or so. And every time that the server would change their certificates, it would break the app. And then you have to do a new app store release and so on. So just be aware that this could happen. And there's also a way to pin just the public keys, which is kind of the recommended way here. So if you pin just the public keys, you could, for example, talk to the backend person that handles, or DevOps, or whoever is handling the certificates on the backend, ask them to generate like 5, 2, 3, whatever, public keys, put all of them in the app, so when they rotate on the backend, they can just use one of the public keys that the app already knows, and it's not going to break the app, and you have time to add more as you go. But the implementation in code is very simple. What is hard is this orchestration between backend with renovating certificates the right way that's not going to break the app. So it's like a system thing that is the challenge, not the code itself. You can do this natively just with the security APIs. If you want to go third-party, Apple Swift certificates, it's amazing. It's a very good library that translates a lot of the gibberish in the security API into nice Swift stuff. There's also a library called TrustKit, which is very high level. You just pass in your keys, and it's going to go do like pinning for your entire app. Very easy to use, uses Swizzling. But yeah, lots of ways. It's very easy to do it. Like if you want to do this next level security, like one day you can do it. But for me, I needed to go all the way to mTLS. All right. I did say that I pass in my certificates to the camera, but where did the certificates even come from? Like, I can't just put them in the bundle of the app. They are per user, per camera. So once the user has access to one specific camera, then that certificate's gonna give access to that camera. So I can't just put them in the app, right? Okay, so what are the steps here? First, generate a private key inside the secure enclave. Secure enclave is a special chip inside your phone. It's outside of the core. It's really a chip that is basically unbreakable, and it's only for handling this kind of public private key operations. I asked to generate a private key. I don't have access to the private key. Nobody has access to it. Absolutely nobody. It stays there, it never leaves, and it's very, very secure. So after I generate a private key, the only thing that I can get is the public key, because the public key is fine to leave that very, very secure place. So I get this public key, I send it to my server with a certificate sign request. They are going to sign me a certificate, give it back to me, and I save that to the keychain. All right, so now I do have a certificate. All right, but if you look at the API here, it doesn't ask me for my certificates only. It doesn't ask me for my private key. It asks you for an identity. Okay, let's do like Mayans and Aztecs did and just look at the documentation instead of asking ChatGPT. So SEC identity, if you look a little bit, it's a private key plus certificates. Okay, that does make sense. You can see that this API is iOS 2. It's very old. It does not even have a constructor for this class, and it's kind of tricky to even get an object for this. But the easiest way that I found was get the private key in the secure enclave. It's a keychain, but it's secure enclave. I'll talk later. Get those certificates into the keychain. Those I put separately. But if I query for a SEC identity, the system is going to do some magic inside there, and it's going to return me a SEC identity. Not really documented anywhere, but like on page 2 of some Apple forums and an angel that replied to their own questions, that's how I found this. And like it is very, again, like page 3 of Apple forums that I find as answers. Like you can use secure enclave keys, but if you use like the nice API, it does not work. You have to use this ugly API, and you have to put this specific tag here. And if you don't put this, if you put this, it's gonna think it's in keychain, and the system's gonna understand like it's a keychain key, even though it is in secure enclave. Again, not really documented anywhere. And this is the code to query for a SEC identity inside a keychain. I am not gonna talk about this because this makes baby cries. There's force and reps that are mandatory. You literally cannot get rid of the force and reps here. It's horrible. But still, it works. You put in a file, leave it there, put a comment, don't touch this, and leave it there. But okay, I do have an identity here. So now I can just reply to the challenge, and it's gonna work. And I did talk before about including a signature validation. That means that even if someone steals the certificate, so backend is sending me the certificate over the network, like you can think that it's not really secure, but it is. That certificate only works if it leaves from this specific phone. So that certificate only works for this phone because the private key is in here, in this chip that's inside here, and it's not going to work for any other device that sends that certificate to the camera. So even if a hacker stole a certificate, that's public, that's nothing. They will not get access to the camera. All right. I did have some challenges that I had to go through to talk to this. Lots of workarounds, which I am going to, again, teach you some Portuguese. The right word for this is gambiarra, which is, you're going to see what is a gambiarra here. But still, what if you don't have access to the URL session? I did a nice little class that handles everything, and I hid it inside the code, and it stays there. But what if you don't have access to it? So third-party libraries. Sometimes you need to use a library that does not give you access to the URL session itself. Some options, you can fork it. Hard to keep updated. You can put a pull request if it's open source. It might take a while to get accepted and get the right back and forth. Or swizzling, which is what I chose to do here. Just replacing that one specific method so I don't have to touch library code, and I just swizzled that one specific method so I can put my certificates there, and it works. And the love of my life, AV Player. Well, AV Player was a challenge on its own. We don't use AV Player for the streaming of the video itself, but we do have a feature where you can have access to 24 hours of video. And 24 hours of video is a very big file. And it's actually not even a single file of video. We use mTLS format, which means that it's not one big file, 24 hours. It's like thousands of 30-second videos that the system knows how to handle it. AV Player is absolutely perfect for this. It does everything for you. You just pass in a URL, but it does not have any access to the URL session. It does not have any access to security. So the file looks something like this. It's a very big text file that tells you like what segment and what part of the file, what part of the video it should be getting. I did a whole blog post about this, but I'm going to summarize in 1 minute just so you can feel the pain that I felt. So basically, AV Player has a delegate function to respond to challenges. And you see, well, that's exactly what I need. So you implement that. It's never called. You search again. Oh, it's never called because you're using an HTTP video. OK, what can I do? But it's a custom format. I put a custom format, custom domain. If I put a custom domain, it is called. But now AV Player does not know how to get the video by itself because it's a custom domain, it's not HTTPS. Then you find yourself implementing resource delegate, and it's like horrible. You're handling with bytes and arrays and things that you don't really want to handle. Using AI and some examples online, you get it working. Yes, it works for MP4 formats. Does it work for HLS? No, it does not. I wasted 2 weeks on this until I figured out it does not work. So I need to go back to my gambiarra. So I take this file, I get and I change it without them knowing. I change it to a local host. Every single video, instead of pointing to the camera, it's going to point to a local host. And I use a reverse proxy. Basically, I put myself in the middle using a local host that I create on my phone. I put some tokens to ensure nobody's going to steal that information. But now AV Player, instead of asking the camera directly, it's going to ask the local host. And it handles everything. Like if you scroll down to hour 325, it's going to ask for segment 2048. I'll just pass in whatever the request they gave me. I'll pass it to the camera, put the certificates, do everything securely. And then with the response, I respond to AV Player. And AV Player doesn't even notice that it's not calling the right endpoint. It's very weird. I hope they fix it someday. But still, now I can pass in and handle certificates. All right, I know it's a lot. Most of you are probably never going to need to use mTLS, but it's interesting to know some concepts of network security. So in summary, I talked about certificate pinning, which is making sure you're talking to the right server, and that server is the one that you trust. I also talked about mTLS, which is doing this both ways, having the server send you the certificate and you send the certificate as well. I talked about using secure enclave and keychain to store those values securely. Keychain is not only for, you usually use just that generic password. You have other options to store certificates, private keys, and other things. And some of the gambiarras that I had to do to get this to work across the entire app, like enforcing this on the entire communication to the camera, was a challenge. All right, I don't know if we have time for questions, but feel free to get there, and, well, I hope I talked to you something interesting today.
Yeah. I think, I didn't check actually, but I think we have time for one question, if there is one question, I think. So, do we have one question? Yep.
The guys that ask good questions.
Hello. My question is semi-off topic, let's say, but you made me interested in that. Because as far as I know, methods with swizzling of methods in the binary is not allowed by the App Store. So am I wrong, or?
So swizzling is not kind of allowed for internal methods, like internal things. But if you're swizzling your own code or your own libraries, there's no problem. TrustKit is a very known library for certificate pinning, and they use swizzling to kind of give like a user-friendly way to override all of the URL sessions across your app. If you're swizzling your own stuff, they don't care. Like, you can do whatever you want. You do have to do it carefully, just to avoid, because things can break without you knowing. But
yeah,
if you're swizzing your own code, they don't mind at all.
All right, thank you.
Yeah.
We have time for one more question. The only reason why Arcadius wasn't asking questions is, I guess, because he was nervous.
Yeah.
So I'm just saying for all the speakers coming, be ready for the question.
All right. You talked about the problem with certificate pinning, that you need to incorporate the certificate or the public keys or a bunch of public keys into the bundle to make sure you basically handle certificate renewal correctly. I'm wondering, what's your stance on the method of using CA pinning versus certificate pinning? Do you think it's any less secure, or what kind of problems are you seeing when you just use CA pinning? Because that's more or less kind of solving the renewal problem.
Yes, so in what I read and learned about this, that's pretty good enough for most apps. So the thing is that I'm thinking you're talking about like having a certificate authority and the trust that I forgot the name, but still, like, that will tell you if a certificate has been corrupted, but it takes a while. So it gives you a notification. It doesn't block in real time. It might give you a notification that the certificate was issued for your domain incorrectly and it could be hacked. But until you fix it, the app would be vulnerable. So for most apps, that would be totally okay. But for some high-stakes app, like having certificate pinning, it doesn't take a lot and increases a lot the security. So I don't know. I think it's a good trade-off. It depends. I think every company needs to decide.
All right, so let's give her a round of applause again.